Hello everyone, my name is Erica Avery and I have prepared this PowerPoint presentation in regards to relative risk, odds ratio, and rate ratio. Relative risk is one of the most intuitive measures in epidemiology. It is used to describe outcomes associated with predictors or exposures evaluated in RCTs and cohort studies, both retrospective and prospective. In general, the relative risk may be used anytime there are data that follow exposed and unexposed persons forward in time to assess for the outcomes of interest. Odd ratios are a measure used to describe associations emerging from case control studies. This uses the same notation within the 2x2 table to describe them. This table is used to describe frequencies of data. This design is key to their analysis and interpretation. However, to use an example that is set up as a cohort study, as we have done previously, would be inappropriate. Measures and designs are integrally related, and it is not correct to change one without changing the other. Rate ratios are closely related to risk ratios, but they are computed as the ratio of the incident rate in an exposed group divided by the incident rate in an unexposed or less exposed comparison group. An example of this would be the number of events divided by the person minus the time. In this slide, we have a summary of definitions. This table here explains some measures, which we have our risk, odds ratio, and rate ratio in this column. We have our formulas we are going to use to compute some of our work later on within this presentation. And we have a range and important values section. So in the formula for risk ratio, we're going to be using the number of events divided by the population at risk. In the odds ratio for the formula, we're going to be using the probability of the event divided by 1 minus the probability of the event. And in the rate ratio, we're going to be using the number of events divided by the person minus the time, which we just saw previously. We will also keep in mind the range and important values when computing our data. Before we get into our assignment, we need to understand the 2x2 table. So here, the above table, or the 2x2 table, is an example from this week's assignment. You will notice the alphanumeric characters for each column. This will help us plug in the appropriate numbers for our formulas when searching for a desired outcome or result. This table is constructed from information provided and based on research or findings, which discusses those affected or exposed and or those not exposed. This can also be the case for those with the disease and without. In this slide, I've just provided another example of our 2x2 tables. So here we can see that we have the disease and exposure, and in here you'll see the alphanumeric characters in a much simpler form. Later in the slide, we're going to get into some of the formulas that you see here for the relative risk and the odds ratio. With this in mind, piggybacking off of this first example, in this table, for the exposure you see those that are exposed to smoking and those that are not, and up here is the myocardial infarction or disease for those that are positive and those that are not exposed or have it. And we can conclude using these numbers the relative risk and odds ratio. So in this slide here, we've gotten into some of our formulas. So this first one is our risk ratio. And you can see for our relative risk, we have A divided by what would be A plus B divided by the total of C divided by what would be C plus D based on our 2x2 table information. For this formula, we'll be looking at the odds ratio, and we can see there's a couple different ways to compute it, but this would be our common formula or method we're going to be using a little bit later on for our assignment. The last formula I'm going to explain is our rate ratio, and we can see here just in previous slides that the rate ratio is the incident rate or the first event divided by the incident rate or second event, where the incident rate is the occurrence of an event over person minus time. For example, person minus years, which we will also conclude in our assignment work later. Incident rate equals the events divided by person time. Measures in action. Here are some of the items we were given. For each city, we are going to calculate the risk, odds, and rate of stomach cancer among heavy drinkers and non-drinkers. Next, we will calculate the relative risk odds ratio, the rate ratio for stomach cancer among heavy drinkers as compared to non-heavy drinkers. In this chart, we can see we have two cities, Atlantis and Camelot. We'll use both these tables when converting our analyses and data for finding the risk, odds, and rate. When solving our rate ratio, we must not forget the person minus time. In Atlantis and Camelot, we have imperative data that we must conclude when solving for the rate ratio. The assignment we were given asks us to solve for some of these measures we have here in the left-hand column. Our population, which was provided based on heavy drinkers, non-heavy drinkers, heavy drinkers compared to non-heavy drinkers, and so on. We have our first city, Atlantis, and then our second city, Camelot. So you can see here in the first column, we are asked to measure the risk of cancer among the population of heavy drinkers. We can see how this data very similarly goes down, asking us to solve for very similar problems. So the first couple of columns here we have risk of cancer. The next two we were solving for odds of cancer, which you can see our findings here. And you can conclude how we found these results based on the 2x2 table in the previous slide. The rate of cancer for heavy drinkers, and then the rate of cancer for non-heavy drinkers. Again, we are utilizing our person minus years formula for rate. However, I do want to point out, as we go down for solving the rate ratio for getting cancer, this one we found was the most difficult for students to catch on, so I'd like to describe this a little bit more. So in order to solve for this first column here for Atlantis, the rate in those that are heavy drinkers, we'll be utilizing our odds of cancer. So that would be 18. Not necessarily this number here, but we're going to be using the 18 number divided by 985. So if you see our column here, the rate of cancer, we have 18 divided by 985, which we already have the answer to, which is 0.018. So we're going to plug this in here, and we'll keep this in mind. The next thing we need to do is find the rate for those not drinking or those that are not heavy drinkers. We're 2 divided by 1,000, which equals 0.002, which we can also conclude is right here, the rate of cancer. So we've already solved this. So really we're just backtracking, plugging things in, solving rate ratio for getting cancer. So it's helpful that we've already done these two steps. Then what we'll do, we will divide our 0.018 divided by our 0.002. You can see, once we've gotten the numbers we need to divide appropriately, here in this column, we end up with 9.137. And we're going to do the exact same method when solving for Camelot. So you can see down below, we've already pulled these two numbers that we need, and we received 2.64, the rate ratio for getting cancer in Camelot. Again, we have to remember when using a risk ratio, an odds ratio, or rate ratio, we need to be certain we're using it appropriately. These formulas and calculations are an integral part of understanding the 2x2 table and how to solve exposures and diseases. I want to thank you all for attending this session and viewing this slide. I hope you enjoyed. Thank you.